Hi everyone. So hope you all are keeping well. So we are going to have a series of tech talks. So as you all know, today is part 1. So speaker for today's session is Amith Mendis, and he will be speaking on AWS serverless implementation. So over to Amith.
Thank you, Tilna. Hi all. First, I'll discuss about the title of this session today. We are going to talk about AWS serverless implementation. In a nutshell, we can say we are going to discuss about build and run applications without thinking about servers or server maintenance. First of all, let's think about life without serverless. That means now you have only traditional architectures and you are planning to develop a HR system, and you think to start it small and eventually grow it into a system which can provide services to multiple companies, maybe multinational companies, multiple multinational companies. Then the thing is, since you are starting it's small, you are not have a budget for the infrastructure. Let's think you have $500 budget for your infrastructure. Then how you are going to implement the infrastructure for this project? That will be a question for you. Right? Then let's think about the first option. You can buy a physical server, but it's not feasible solution here because physical server will way more, that means price may be way more higher than $500. Therefore, you will not be able to buy a physical server. Therefore, you will lease a virtual server and put your application server and DB server into it and host your system. Then what are the issues and how to handle those? That means some of the issues we are going to discuss about. We can discuss the issues and think how to handle these situations using traditional architecture. Scalability. Let's think, because of now you have $500, you have got a decent server, but it gets more requests than you expected. Therefore, you have to scale it. When you are scaling it, you will have to put this system into a server fleet or another server and give the access through a load balancer, right? Then you will have to maintain and implement that even before you are going to do this business. That means you are going to host this for that client. Then it will be an added hassle for you to go to another business, and that means acquiring businesses and getting them into your system. Scalability will be an issue. Then high availability and disaster recovery. As you all know, when it comes to multinational companies, they are expecting high availability and disaster recovery. Normally more than 99% high availability, and we should be able to handle disaster recovery pretty well. Then you will have to think about disaster recovery aspect of it and high availability aspect of your virtual servers. Then you will have to think about data backups, live data backups, how to handle disaster recoveries. If one server fails, how to up it. And there are a lot of things you will have to go through, and maybe you will have to change your architecture based on that. That's another concern you will come up with in traditional architecture. The third one, the most important one, the infrastructure security. Let's think, that means again, if you are going with a big company, then they will need proper infrastructure security. Therefore, you will have to set up the firewalls and everything has to be in place. Therefore, you will have to put a lot of time and effort to manage your infrastructure security. If you get a security update, you will have to security patch. You will have to do it for entire server fleet or something like that. That means you will have to manage them. The maintenance effort will be high. And infrastructure updates. If your OS get updates, then you will have to update your old OSs in your server fleet. There are a lot of things that you have to consider. That means downtime and how to roll back if anything goes wrong. Then that means there are a lot of considerations you will have to do when you think about infrastructure updates. Then multiple versions. Let's think now you sold your applications to 3 companies. Let's say company A, B, and C. And now company D you have approached company D and they are asking for another requirement set which can't be provided within the current system, which you need some implementation. Let's say it's version 2. Now you have to think about how to provide all these services for new version also. While you are having the old version for company A, B, and C, then you will have to do the same infrastructure setup and everything for new version, right? It will be difficult for you. Therefore, virtual server environments, you are getting these concerns, and you will have to solve these concerns, and you have to maintain the infrastructure, and you have to maintain the resources. Now, let's think about life with serverless. That means if you have serverless infrastructure, how it will be look like. Now, let's think scalability. It will handled by vendor or the service provider. In our case, if we take AWS serverless, it will be AWS, Amazon. And high availability, they are promising us the high availability up to 99.999 for most of the services. And disaster recovery can handle through availability zones and regions. We can configure it to handle disaster recovery also. Therefore, this will handle by AWS itself. We don't have to worry about it. Infrastructure security, they will handle it. Infrastructure updates, again, they will handle it. Multiple versions, we can configure them easily. If you want, there are ways to configure them. And even having separate multiple versions is not an issue here, because you don't have to worry about setting up the infrastructure and all. Therefore, this is way easier than managing a traditional infrastructure and updating it and maintaining it. Since you are not updating, maintaining, and thinking about infrastructure much, you don't have to worry about it, and you are free to focus on solution without thinking about the infrastructure. The main advantage of this is the cost. That means you will get all these features with less cost. That means you are not costed for your idle time. Normally, when you take a virtual machine, you will have to think about the highest usage, and you have to buy that server or the resource based on your high usage, and you will have to pay for idle time also. Now, with this serverless or managed service architecture, you don't have to pay for idle time. You will pay for what you are using. When it comes to AWS serverless, these are actually subset of AWS serverless offering. There are much more than to this. I will go through some of the services for database, gateways, security, messaging and queues, compute, storage, network, content delivery, streaming analytics, user management, Internet of Things, monitoring and login, machine learning. We have a lot of managed services for different aspects of software development or software delivery. Then you don't have to worry about managing this infrastructure. That means infrastructure of these services, AWS will manage it, and you just have to worry about how to use these tools and get your work done with best practices. In this session, what I will do is I will go through AWS Lambda. It will be an introduction to Lambda, and next session we will talk about complex concepts about AWS Lambda. Let's see what is AWS Lambda. AWS Lambda is an event-driven serverless computing platform. That means, what means by event-driven? Now, event-driven means these lambdas will active only by an event trigger. That means you need to send an event to trigger these lambdas. If not, they will not work, they will terminate. It's a serverless computing platform, which means you can put your business logic and compute them within AWS Lambda. One thing is, it runs in containerized environment. We call them, that means these containerized environments has been created using Firecracker VMs, micro VMs. It's a open source project which done by AWS, and they are using it for AWS Lambda and Fargate. Firecracker micro VMs are very small VMs which can initiate instantly with less footprint plus less memory and CPU usage. This is a function as a service. Lambda is used as a function as a service in cloud. Here you can see abstraction level. When you use servers, you will have to That means it's very low abstraction level. You will have to think about OS, application server, database server, and all of these things, firewalls, and all the tiny details you will have to think about. And when it comes to virtual machine, it's more abstract. You don't have to go to hardware level, but you'll have to worry about the maintenance. Next level of abstraction is containers, and the last level of abstraction is fast function as a service. In function as a service, you just have to worry about the function you are going to write and what's the best practice to write them and implement it, Lambda. Now let's see the anatomy of Lambda functions. First, we have compute substrate. It's the hypervisor. Hypervisor is a virtual machine monitor which we can create and run virtual machines on top of it. And this is the infrastructure which function containers run on. That means hypervisor can have thousands of function containers running on it. And we have function container, which is Firecracker micro VM. As I said earlier, it's a AWS open source project they have started, and they are using Lambda. And within this Firecracker micro VM, there are language runtimes like Node.js, .NET Core, Python, Ruby, Java, and Go. They say we can have custom runtimes also within these containers. Now, even though we are talking about hypervisor, Firecracker, micro VM, and language runtimes, we don't have to manage them. They will manage it for us. We just have to configure what language runtime we want and what's the memory capacity we want in micro VM. Then they will proportionately they will add CPU power and network for that. It will handle by AWS itself, and we just have to write our function and upload it. And when we think about important aspects associated with Lambda, you can see we have trigger which activates the function, and the actual function. This is the function we write to run. And resources. Resources are the things which related to the function. That means if we write something into S3 bucket, that's a resource which related to this function. And if we get something from Cognito, it's a resource which related to this function. Likewise, there can be more resources which related to this function. Now we have trigger, actual function, and resources. Trigger will activate the function. Function will use resources and run. And these are some of the triggers which can invoke Lambda. That means with these services, we can invoke Lambda, trigger Lambda functions. Most of the time, we use API gateway or application load balancer to access Lambda from outside of AWS. But inside also we can access Lambda. There are two methods they say which we can access Lambda. One is synchronized way, and the second one is asynchronized way. We will discuss it on next session. But these are the tricks. Now let's see how Lambda execution happens. When event comes to AWS Lambda, looks for active Lambda functions available. That means if we call a function name in containers, if it can't find that, what it will do is it will get the source code from S3 bucket, download it, and set up the runtime environment and initiate the function. We call this process called start. If you don't have any active Lambda function, we will have to start a Lambda function. This is the process of that. And let's see how whole execution will happen. Now we know about the call start function, call start process, and after that only it will execute the Lambda function. Now here you can see response time is aggregation of call start time and execution time, right? If your execution time is 500 milliseconds and your call start time is 200 milliseconds, it's 700 milliseconds now. Therefore, it will affect your customer experience. I'll describe how to reduce it. First of all, there are three facts which call start time depends on. First one is your code package size. If your code package size is huge, then it will take a lot of time to download the code and init the function. Therefore, you will have to be careful about if you are a node developer, you will have to be careful about node modules you are going to use, and you will have to reduce the size of the node modules when you are deploying it. There are ways to do it. We can discuss it later. And your runtime environment. Normally, Node.js, Python, and Go runtime environments are starting within a fraction of second, but JVM will take some time to start. Therefore, cold start can be an issue when it comes to user experience. And settings of your Lambda function. First one is your code package size. The second one is your runtime environment. The third one is your Lambda function setting. When we talk about settings, we are talking about VPC. If you are setting up your Lambda within a VPC, it will take long time to start. Therefore, they advise us not to use Lambda within VPC if it's not required. If it's required, there are ways to reduce cold start time. I'll explain that. Now, these are the three things which will impact on your cold start time: your code package size, runtime environment, and if you are running it on VPC, it will take some time to start the function. And since your cold start time effect for your users, let's think how to reduce it. You will have to think about your code package size, and if it's that means you have to make it small as possible to make it easy to download. And don't put Lambda function within a VPC if it's not required. If it's required only, you will have to put Lambda function within a VPC. And you can use scheduled ping events to keep them alive. That means every 5 to 15 minutes, you can have a scheduled ping event just to keep them alive. Then you will think that if I send a ping event to keep them alive, how it will work, right? That means you can't activate a function by calling with some function parameters because it will save in database, right? Therefore, in Node.js, there is a library called Lambda Warmer. Likewise, there can be, for other languages, I think there are Lambda Warmer functions. What it does is you can create an event to do Lambda warming function only, and it will catch it from the start of the function, and it will warm the Lambda. That's all it will do. Then always Lambda will be activated. You will have to ping. That means you will have to have scheduled ping event to keep them alive. Now, Lambda execution. That means this is about warm start. That means earlier we have discussed about the cold start. This is warm start. That means first time when a Lambda function starts, initiated, and it's alive, when you get events, it will get only the time to execute the handler. Therefore, it will be less time, way much faster than the cold start. Therefore, what they tell us is to use, that means create APIs as much as frequently, and it will be warmer. And if you need to improve, that means if you have a cold start function, they suggest us to create warm start calls using ping events. Right, now I'll go through a demo, but this will show you how Lambda functions. This will show you how to create a Lambda function. First of all, you should have an account to access AWS, and I will sign in. Right, here you can see this is the AWS management console, and you can see the services which AWS provides. Now we are going to discuss about Lambda, one of the compute services they are providing. I'll go to this first and give you some idea about the Lambda. Here you can see runtime environments, right? .NET Core. I think Ebex team can understand this code, and this .NET Core, and Go runtime environments, Java, Node.js, Python, Ruby, custom runtimes. And let's think we have selected Node.js. Now here, now it's deployed. Now this is for introduction. I'll show you how it scales up. Here you can see there are three ways this Lambda function triggers. First one is this phone. it will go through IoT backend and it will call Lambda function. Stream analysis can call Lambda functions. And here S3, this photo will go to S3 bucket and it will call this Lambda function. You can see when I send a lot of requests, it will create multiple Lambda instances to handle it. It will scale up instantly. This is the way it works when you have a lot of requests, and it will scale up instantly. And the next thing is the cost. You can see here for around 700 requests, cost is 0, right? Now, when it's more than 1 million, the cost become 0.02 or something. That means cost is very less for Lambda functions, and therefore you don't have to worry about the cost much when you're using Lambda. And we'll create a Lambda function here. There are 3 ways we can create it from console. We can author from scratch, use a blueprint, browse serverless app repository. I will use a blueprint for this. I'll take hello world Lambda function. Now you can see I can give my I have given my function name, and you can create a new role with basic Lambda expressions. That means here actually you have to give permissions to Lambda to access these, that means the infrastructure. Here I will create a new role with basic Lambda permissions. It's a IAM role we are creating for. This is the role which they will create for me, and this is the code, and runtime is 12.x. Now I'm creating the function. Now this code will go to S3 bucket and set up the infrastructure for this Lambda function. Now we have it. This is the Lambda function console, which we can see all the details about the Lambda function. Now you can see this is the code. You can change it from here. Even if you want, you can change it here. And I'll create a test event for this. I'll not change this, and I'll, oh sorry. Now I can run this test event and see the output. Now what will happen is, that means now here it will happen all the process which I have explained earlier. It will get the code from S3 bucket and put it into micro VM, and it will initiate the runtime environment and set up the initiate function. After that it will execute it. Here you can see the time with cold start for this function. The duration is 50, that means more than 50 milliseconds. If we call it again and again, you will see now it can reduce up to 1 millisecond even, right? These are the times which we call, that means we are calling warm start functions, which does not require the initiate process, cold start process. And here you can see now it's way faster. That means it takes only 1.18 milliseconds. If it's go through the cold start, it takes more than 40 milliseconds most of the time. Here you can see build duration. Normally it built for 100 milliseconds. That means 100 millisecond blocks. Therefore till up to 100 milliseconds of this duration, they will cost us 100 milliseconds. And the resource configuration, I have put the default resource configuration is 128 megabytes for RAM, and the maximum usage is 65 megabytes. Here you can see the CloudWatch log, which has created for this Lambda function call. If you go to that, you can see this is the CloudWatch management console. Here I can see this, and if you go through it, you can see the CloudWatch log, which contains details about the Lambda invocations. And for this, actually, to do this, they have created a IAM role for Lambda. We can go to permissions and see this role. That means this is the permissions they have given Lambda to access CloudWatch. Earlier, I have explained you that Lambda can, that means we have three main parts: trigger, function, and resources. This is one of the resources which Lambda used to log. And to access that resource, we have to give IAM role for that. This is the IAM role. And you can see here, it says CloudWatch logs. We have write access. That means this role have write access to CloudWatch logs. That's how we give permissions to Lambda function. That means to access any resource using Lambda function, we need to give IAM role for that. And if we go back to this, configuration, now you can change this code if you want. Let's change this and see what will happen. Let's throw a new error. Now when you change it, it will impact here. You can see the change. This is how Lambda works. That means basic execution will happen in Lambda. And these are the basic settings you can change. You can change the runtime, but you will have to change the code for sure to change it. And this is the handler function. And you can change RAM up to 3 GB, and it will reduce the execution time if it's a huge function, because with the memory allocation, it will change the CPU allocation and network bandwidth for this function based on the memory allocation. If it's less, the CPU which allocate for this function is less. If it's high, then CPU is high. The allocated CPU is high, and there is a timeout which we can go up to 15 minutes. We will not be able to go more than 15 minutes in Lambda function. That means we can't do it. The maximum execution time is 15 minutes in Lambda. If it's more than that, it will fail. And here we can see again what's the role we are using. And I will go through the other configurations and more detail. That means how to connect this into API gateway, how to connect this into DynamoDB, and that means how to call this using S3 bucket. I'll explain it on next session. But for now, I'll give you a basic introduction to Lambda. And let's go to the last slide. The benefits and drawbacks of Lambda. We can have a faster development because we don't have to worry about the maintenance and scalability and other aspects. Easy operational management. We don't have to worry about operational management because it will handled by AWS. Scaling benefits of fast beyond cost. This is one of the best things which gives by Lambda, because you don't have to think about the maximum utilization and plan based on that, because if you are going with a virtual server, you will have to think about the maximum utilization and allocate your resources for maximum utilization, even if you are not using it. Here, you don't have to worry about it. Based on your utilization, the scaling will happen. Reduction in operation costs. You can see that normally with 128 MB Lambda functions, you will get that means $0.2 per 1 million requests. Therefore, it's cost effective. And drawbacks, there are some drawbacks in Lambda. We will have to think about it carefully when we are implementing Lambda. We don't have control over the environment which Lambda hosted on, and execution durations. You will not be able to put the functions which take more than 15 minutes to run in a Lambda function. And startup latency, as I discussed earlier, cold start, because this can lead to user experience issues if it takes a lot of time to do the cold start and if you are not managing it properly. And stateless, because Lambda is a stateless way of implementing services, because you can't manage state within a Lambda function. That means you will not be able to manage your state, some type of a state within data within Lambda. Therefore, you will have to use database or file system to manage that state, and you have to retrieve that data and do the operations. Therefore, you will have to have this in mind. This is stateless. And testing, you will not be able to do load testing, as there is a concurrency limitation in Lambda, which you can put concurrency limitation to avoid DOS attacks. Therefore, if you are trying to do a load test on Lambda, it may think it's a DOS attack and it will shut down the service. Therefore, you will not be able to do load test, but they guarantee that we will get the scaling capability. Therefore, we will not be able to do load test, but it should be fine. DR test, you don't know what servers are working. That means what servers are the servers which these services are hosted on. Therefore, you will not be able to down it and see how DR situation will handle. Therefore, you will not be able to do a DR test, but it's okay because they are guaranteeing that. And integration testing is difficult because of this is a microservice architecture. It's not easy to do, but integration testing can be done. It's difficult. Debugging is an issue here because you can't run Lambda function as same as you run in AWS and debug it. That's an issue when it comes to development. These are the things that you have to consider, but I don't think any of these things are a huge issue for developers or testers because they are managing a lot of scenarios. These are the things you will have to care for. The next session I'll talk about the event and context, Lambda execution. That means again I will show you the examples of cold start, warm start, and initialization versus handler. The invocation methods, that means the two types of invocation models, push and pull, concurrency and scaling, failure and retry behavior in Lambda, versions analysis, and monitoring of Lambda. For today, this is what I'm going to present to you about introduction of Lambda. Right. Thank you. If you have any questions.
Okay, thank you, Amith. So hope you all understood and found it interesting. So as I said in the beginning of the Tech Talk session, the next Tech Talk will be, the part 2 will be on the 10th of July. So highly appreciate your participation. Thank you everyone for taking part. Have a nice day.